Okay, I want to talk about system of simultaneous equations and two unknowns. Example. Okay. 2x plus 3y equals 12, 4x minus 3y equals 6. We want to find the values of x and y that satisfy both at the same time. In other words, simultaneously, which is why we call them simultaneous equations. You want x and y that solve both of them. Okay, same x, same y goes into this, it gives you a solution, goes into this, it gives you a solution. Okay, there are many ways to solve them. The three basic ways are graph them and see where the graphs cross. Okay, that's what the first thing we're going to do, because that's a geometric interpretation. I like the way the MyOpen Math here has been set up, because that's the first thing it does. It shows you the graphical. Okay, I've been trying to teach linear algebra to people who don't understand the geometry and the graphical part of it, and never seem to learn it. And it's bad prerequisite courses. Okay, here's the first thing you need to learn. Okay, so we graph. Easiest way to graph these equations is by the intercepts. Let y equal 0, you get x equals 6. Okay, if y is 0 here, 2x equals 12, so x equals 6. So we got the point 6, 0. If x equals 0, y equals 4, so we have the point 0, 4. And there's a roughly straight line. Okay? So, points are on this line if and only if they satisfy the equation. So every point that satisfies the equation's on the line, every point on the line satisfies the equation. Second equation. Okay, 4x, if y is 0, 4x equals 6, so x equals 1.5. Well, if there's 6, half of 6 is 3, and half of 3 is 1.5. Okay, so we have three halves, 0 on the graph. And if x is 0, negative 3y equals 6, so y equals negative 2. So negative 2, well, there's 4. So there's 2. So here's negative 2. And so the graph of this equation goes through these 2 points. Okay, so this is the graph here of y, of 2x plus 3y equals 12. And this is the graph of 4x minus 3y equals 6. And every point on this line satisfies this equation. Well, this point is on both lines, so its coordinates satisfy this equation and this equation. Okay, so the coordinates. Satisfy both equations. So now all we have to do is estimate the coordinates of these points, and we have an estimated solution to the equation, to the system of equations. Well, it looks like this point is very close to 3, x coordinate, and it looks like the y coordinate is very close to 2. Okay? So this point looks like and it's not 2, 3, it's 3, 2. Looks like the point 3, 2. Okay, so we're going to try that. So, come back up to the equation. Try x equals 3, y equals 2. I didn't make any attempt to make this equation come out even, but it kind of maybe does. Yeah, it looks like it actually works. Okay, that's no big coincidence because I did try to make the intercepts come out integers. Okay, but there's no reason, even at that point, that I could expect that these solutions would come out that nicely, or even more, that the graph would actually show me the right solution, because it's a hand-sketched graph. Okay? Okay, but it turns out that it actually works. And don't expect that this will always actually work. If I'd made this 11, this 7, so I'd had to estimate fractions and everything, my graph would not have come out that nicely, and I wouldn't have had anything really close to an integer. If I make an accurate guess, that looks more like 2.9. You know, this one still looks pretty much like 2, but maybe a little less. So an honest estimate, an accurate estimate, would probably not have hit 3.2. And, yeah. Okay, so we get 2x plus 3y equals 12. Well, if x equals 3 and y equals 2, we get 2 times 3 plus 3 times y equals 12. And clearly that works. 6 and 6 gives you 12, so it worked. Very, very surprisingly. Okay? I mean, I really am surprised because I wasn't all that careful with the graph. It was just pure luck. Okay, anyhow, you have then 4 and minus 3. You should get 6 when you plug in the x and the y values. That's 4 times 3 minus 3 times 2 equals 6. Big surprise. Okay? So, it worked. Now, with the graphs that you're probably going to have, and actually you're probably going to have a graphing tool in MyOpenMath. So, I mean, you've graphed straight lines. You know how to use the graphing tool. It might well be that you don't need to do them by hand, that you can actually sketch them on the graph. I'd still do a couple of them by hand. It causes you to think about things you wouldn't think about when you're doing it by computer, and connects you to it much better than the graphing tools that you're going to have. But the graphing tools are pretty good. I don't object to them as long as you do a few things by hand. Okay, and engage that part of your brain. It just holds better, it works better. Okay, so there we have it.